Now we're going to talk about graphing a direct variation. So remember now, direct variations in the form of y equals kx. And in that form, k equals the slope of a linear function or linear equation. And we can further define slope as slope equals rise over run. Rise being how far we may be going up and down the vertical axis, run being how far we may be moving left or right along the horizontal axis. And so we're going to be graphing, we're looking at 4 equations here, and we're going to be graphing those. But the first thing we're going to do is determine a ratio. The slope is in the form of a ratio, rise over run. And then on the next slide, we're going to go to GeoGebra and graph those using rise over run. And then I'll probably take a couple of those and actually graph them on a graphing calculator, so we can begin to get a little experience with that. So first, let's look at this ratio here on this first one on the top left, y equals 6x. Well, my ratio is 6 over 1. I'm going to have a rise of 6 and a run of 1. Down here in the bottom left, we got y equals 2/3 x. So again, this is already in my ratio form. My ratio is just actually 2 over 3. A rise of 2, a run of 3. And then here on the third one, we've got y equals negative 5x. And again, my ratio is negative 5 over 1, or it could be 5 over negative 1. Both of those would give us negative 5. And then the last one, we got y equals negative 3/4 x. And again, we got a couple of choices. We can have a rise of negative 3 over a run of positive 4, or we can have a rise of positive 3 over a run of negative 4. And we'll get a little bit better sense of that as we put these on the graph. Hold on. All right, so here we are over on the graph paper, and we're going to graph that first one with y equals 6x. So I'm going to hit my little point function. And I know that I've got an intersection, and my x and y intercepts are at 0, 0. So I'm going to put a point right there. All right, and then I've got a rise of 6 and a run of 1. And both of those would be in the positive direction. So I'd go up 1, 2, 3, 4, 5, 6. That's a rise of 6. A run to the right, positive of 1. And I'm going to put a point there. Now, I can do a line through any 2 points. So let's go to the line function. We'll hit the line. And I'm going to go through point A and through point B. Now, I want to illustrate something. Okay. All right. Now, I didn't want to do that. Let's get rid of that. Okay. We'll go back to my original line. All right. Now, I could also go down 6 and to the left one, negative 6, moving down the negative side of the vertical axis, down 6 and over 1. And in fact, if I were to go do that, I should see that when a rise of negative 6 over a run of negative 1 should be on this line. So let's go down 6. 1, 2, 3, 4, 5, 6. I better go get my point tool. All right, so we went down 6. We went to the left 1. That's negative 1 right there. And shazam, I actually am on that line. All right, let's graph the second one. Well, I'm going to have a point through the origin. And then we've got 2/3 x. I'm going to just leave this other graph up. Okay, so I can go up to y equals 2, and I can go to the right 3. Both of those are positive. Let's put a point right there. And I can go then to my line tool. And I'm going to put the line through here through the origin and then through point D here. And that represents the slope of a line that's got a 2/3, 2/3, rise of 2, run of 3. And there's my graph of that direct variation. I'm going to clear these. As for new, don't save. I'm going to grab my little hand tool and move this over a little bit. Okay, now we're going to graph y equals -5x. Now once again, going to my point tool, because it's a direct variation, I'm going to have x and y intercepts at the origin, so I'm going to put a point there at the origin. And we got -5, so that's down 5 on the y-axis to the right 1. That'd be -5, +1. Let's go down here, -5, +1. Looks to be right about there. I wasn't quite there. I missed it just a little bit. But let's go to our line tool and draw a line through these 2 points. And there's a graph roughly representing -5x. It doesn't want to let me go. We'll put another point right there. All right. Which is also a -5x. I go up 5, that's +5, to the left 1, that's -1, but +5 over -1 is also equal to -5. And then let's do one last one where we've got a slope of -3/4. Let's see, let's go. Again, we've got here at the origin, we got a point at the origin because it's a direct variation. Let's go down 3 and to the left 4 because it's -3/4, and it looks to be somewhere. I should have put the grid lines on this graph. I don't know where they went. -3/4, and let's put a line through those 2 points. And shazam, there we go. We've got, I actually hit that one pretty good. And so there we go. We have graphs and direct variations. Now I'm going to take 1 or 2 of those and we're going to graph them on a graphing calculator right quick just so you can get a little experience with that. And then we'll move on to the next subject. All right, well, here we are on our graphing calculator. And I'm going to graph the y equals -5x, and I'm going to graph the y equals 2/3 x. And one of the first things I may want to do, you can follow along, when the buttons light up in red, that means I've just clicked on it. I'm going to check my window settings right quick. So I'll go into window. I see that I've got an x minimum of -10, an x maximum of 10. The scale on the x-axis is 1. I got a y minimum of -10, a y maximum of 10, and the scale there is 10. That's good. That's the standard default position, but sometimes I have to adjust that to be able to see the graph, but it will not be able, won't have to in this case. So my horizontal axis is going to run from -10 to +10, and my vertical axis, my y-axis, is going to run from 10 to -10. So then I'm going in here to y equals, and let me move over here and clear what I've already got in here, which you saw that graph. All right. Let's move up here to y1, and I'm going to graph first -5x. And I don't have this screen. I didn't put this screen large enough. Just be careful that you don't use the subtraction button, that you use the negative button, which is just below the 3 on your calculator. So I'm going to hit negative 5x. And let's go look at that graph. All right, so there you go. I'm coming through the origin. And let's see, if I'm going down the y-axis 5 units and to the right on the x-axis 1 unit, that would be negative 5. So there's negative 1, negative 2, negative 3, negative 4, negative 5, and then to the right, positive 1. I can see myself moving through there. And if I went the other direction, if I went up the vertical axis 5, positive 5, I would then have to go to the left 1. Let's see if that puts us on the line. 1, 2, 3, 4, 5, to the left 1, and you can see I'm back on the line. While we're here, let's just go look at our table. I'm going to hit second graph, and that's going to bring up the table. Maybe not. Second graph. There's my table. Okay, and I can see here then that I've got a point here on the origin, 0, 0. There's my x-intercept. And if I'm looking at the change in y over the change in x, let's just look right here. I go from 10 to 5, well, that's a unit of 5. And I go from negative 2 to 1, that's positive 1. I mean, negative 1. Excuse me, that's negative 5. 10 to negative 5, y2 here to negative 5 will give me negative 5 from negative 2 to 1. Obviously, it's going to give me a positive 1 direction, so I've got a negative 5, a rise of negative 5 over 1, and that checks out. Let's go look at this second graph. I'm going to graph it over top of the other one because it was what? 2/3. So I'm going to hit 2, division symbol, 3x right here, and let's go look at that graph. And again, it's passing through the origin. If I go up 2 and over 3, rise of 2, a run of 3 puts me right on the line. So there we go. We've graphed some on graph paper, and then we turned around and graphed it on the graphing calculator.